Good afternoon, everybody, and welcome to the second webinar on US-based lessons learned hosted by EUROCONTROL on behalf of the US-based network of demonstrators support cell. My name is Maria Algar Ruiz. I am EASA Drones Program Manager, and I have the pleasure to be your moderator for this second webinar. Thank you very much for joining the webinar. We have now run about 87 participants. It's going up as we talk. Today is on a Friday afternoon, so this shows the interest that there is on this webinar. Today we have two great speakers that will talk us about two interesting subjects. First, we have José María Báez Cristóbal, Chema for a familiar name. He is the project manager at Galicia Innovation Center in Spain. He will talk to us about the present and future of UAS SandBox, the Galician experience in La Rozas. And then we have Waldemar Krebs, who is the business development director at XSun France. He will talk us about the SolarXOne long distance capacity and BVLOS projects in France and in Germany. And for sure, this is a great example of sustainability and innovation. Before I give the floor to Chema, I want to remind you a few housekeeping rules. So the event is recorded, and the recordings will be sent to the participant and the network members after a few days after the event. Rules of engagement, so you are mute and your camera is switched off. So use the chat and the Q&A features to put your comments. So please use the chat for putting forward general comments or to say hello, but when you want to make questions to the speakers, use the Q&A feature. There is a feedback form that will be open 10 minutes after you have joined the Zoom event. And it will be in the same browser that you have used to launch the Zoom event. We will appreciate if you could provide feedback, as it helps us in the support cell to prepare the next series of webinars that they are of interest of you. With these housekeeping rules, I don't take more of the important time that you have. I give the floor to Chema. Thank you very much, Chema. The floor is yours.
Thank you very much, Maria. I want also to thank EUROCONTROL for the kind invitation to present our CR Center. I will share my presentation now. Oof, excuse me. It was running before. One second, please. That's in. Okay. So, good morning, everybody. Thank you for the attendance of the presentation. We are presenting you the Center for UAVs tests in Galicia, in Spain. The way we will follow is first we will speak about the infrastructure which are already there, developed and prepared, and the tests that we have done during the last years. Then we will speak about an additional facility which will be installed there in September this year, We will then speak about what we are planning for development in the 2 next years, which is the US space simulation set. And finally, we will tell you a couple of words about our plans for 21-25. So CEAR is the Center for Airborne Research. It's placed in Galicia. It's a joint center between INTA, which is the National Aerospace Technology Institute from the Ministry of Defense, and the Galician regional government. It is placed in the province of Lugo. For those who know the Santiago's Road, it's basically 40 kilometers north of Porto Marín, more or less. The investment which has already been done there is 10 million euro, basically. Half of it is for the buildings and half of it is for the technological infrastructure. 80% came from European funds and 20% remaining is funded by Xunta de Galicia. It is our focal point for a program that Xunta de Galicia has been developing since 2015, which is the Civil UAVs Initiative. The objectives are basically to train airpass to fly, to provide users with infrastructures in order to perform flights, integrate payloads, integrate systems, etc., and support the development of new regulations with a view to enable the future safe flights of unmanned vehicles, sharing space with manned vehicles. Okay, after the building construction phase, the center has been equipped. We use public procurement of innovation for it, and it holds, we think, a unique set of technological assets, which are oriented to be a very innovative control test center. The main components are the test control center, which is a place to be able to execute and follow up the different tests. A safety systems, which is composed of a radar, which can, with a range up to 180 kilometers, a communication system which integrates 5 different lines and can be deployed in the ground and in the control center, etc. A very particular meteorological system that allows you to make very accurate predictions following specific meteorological models that have been developed for that. Of course, a data management system. And then we have also a strategic simulator, which allows you to prepare and to simulate the missions before executing them, and to prepare the strategic aspects of the different tests. In 2020, just to see, it was used during 60 days for flights. Okay, if you take into account that it's basically available during 240 days per year, this means that it's one-fourth of its potential use. Most of the flights were done within the programs and projects of the Civil UAVs Initiative. 11 of the days were used by the Skyway program with INTA and Boeing. 5 of the days were used to fly the same unmanned vehicle, the ALO from INTA, but most of them were for the preparation of the other 11 days. So it's basically the same. Then for a Babcock vertical takeoff system of 40 kilograms, used the installations during 25 days. And finally, Indra and Gaerum used the facility during 18 days to fly the Targus oceanary piloted vehicle which is a 1,250 kilos aircraft, and you will see some of the flights we performed there.
How do piloted and autonomous passenger and cargo air vehicles safely share the airspace of tomorrow? It's a question that Boeing and our research partners are answering now in Galicia, Spain. The Galician Skyway project has identified 5 key technologies that must be solved for a future airspace where traditional aircraft and UAVs coexist. As part of the Civil UAVs initiative, together with national and local research partners, we are developing and testing these key technology solutions to ensure redundant layers of safety at the pioneering Rozas Airborne Research Center in Lugo, Spain. Detect and avoid. Power assurance. Autonomous emergency landing. Communication security. Navigation solutions. The development of an aeronautical industry in Galicia is a government priority, leveraging research and development to guarantee competitiveness of the local economy in an inclusive and sustainable growth model. And the Skyway project has contributed to socioeconomic growth in the region through partnerships with local industry. Launching the Newton.
Okay, now we go to see a different test. So what you have seen here is a flight which goes some tens of kilometers to the sea. So we have a corridor which allows us to arrive to the Atlantic. So those are basically the installations, how they are used. The railway is 1,200 meters long, so you can use normal airplanes to fly there. And now we are going to show you what is the new facility whose development is being finished in a couple of months. It's a contingency simulator. This contingency simulator is the final product of a project which has been developed by Boeing Research and Technology in Galicia. The program was composed of 6 projects to seek for individual solutions to different contingencies, which were the loss of link, loss of communication, the loss of GNSS navigation signal, the loss of power on board, the loss of engine thrust, the loss of separation, and the loss of ownership where a hacker tries to get the control of your plane. All of these were integrated in a contingency manager, which is a different project to integrate them. And finally, from there, the development ended with a simulator. The simulator is oriented towards solving contingency analysis and to make trial with contingencies which can be partly real, partly virtual. So this allows you, we will see it later on, this allows you to simulate real operations, to simulate interface with air traffic control in the area, and to take the due provisions in order to allow safe operations and even safe tests when you are testing technologies that are not still 100% reliable. Okay, so this will be a part of the installation in a few months. It allows you to simulate the contingencies that occur, and you can do it simulated, or you can simulate part of it during the mission. Okay, you will see a situation like that in the next video. It's the objective is to create high fidelity environments where you can try different solutions to the contingencies, not only, so to say, technical solutions, but also operational solutions. In fact, during the project, we performed some operational impact analysis, including the air traffic controllers from Santiago, which is the airport which is nearest to Rozas. Okay, and okay, in order to allow different integrations, the system has a modular and flexible architecture to allow to put one module or take out another. Okay, see here you are going to see the video of operational impact on the air traffic control with the simulation of failure of communications, a loss of link, but we must tell you that the aircraft is really flying. Okay, the loss of link is not fully real, but the aircraft is really flying.
Delta Romeo 10007, suelto por la pista 04.
Proceda directo barco y le llamo para más alto. Copiado, procedemos.
Okay, so here you have a couple of pictures of how is the flight simulator cockpit and the simulation operating station. This is what we already have installed there. In the future, we are planning to develop new infrastructures. The next one is a full set U.S. simulation. This is a call for tender that will be issued by CDTI, the Spanish Center for Technology, for Industrial Technology Development, in cooperation with Galician government. It will allow us a number of elements. we, with the current infrastructures, we can provide services for the U1 and part of the U2 of the European roadmap. With the new Galician Skyway simulator, we think we can extend it to fully U2 and part of the U3 phase. And with the new simulator, we will integrate all the elements that we have there. This will allow us to provide US-based testing functionalities for phase U3 and most of the U4 phase of the European roadmap. So the main elements is the simulator will provide advanced simulation infrastructure. It will allow not only simulate, but also analyze operations to change environments, to make part of real elements and part of simulated elements. It will allow the modeling of the different digital services, because it is based on the opinion published by EASA in February 2019, I think, and the different modules are organized in order to simulate every one of the operators. In this sense, you can substitute one of them by your system and try whether it works correctly within the overall system. And of course, it will be able to interact with real systems. We are already used to do that, because many testings, we do it in cooperation with air traffic control in Santiago. The objectives are to model and analyze different operation scenarios, to analyze the efficiency of operations, because we are looking to an industrial and economic sector that will need to be as efficient as possible, to identify, of course, safety risk and define requirements, and to analyze or even test regulatory requirements that can be decided or not. Okay. And for the coming 5 years, we are preparing. We have presented the new Rozas 21-25 plan, and some of the elements have to do with SESAR infrastructure. In order to maintain SESAR as a reference center for UAV test, we will maintain our innovation push, and we will develop new elements. Once we finish the simulator that will be made in the next 2 years, we will go to the next generation simulation from here to 2023. We will have better vision of the final situation of the UAVs in the air traffic. So we will design a next generation simulation. We are going to include 4 and particularly 5G technological environment for the center, and we will try to deploy systems that allow the use of communication links for BVLOS using phone signals. We will include the cybersecurity systems in order to also be able to test anti-hackers and ownership control, and other elements. Those are the 3 ones that will go in the first years, so 21, 22, 23. And we will also go to develop system for detect and avoid, vertiports, new micrometeorology, and of course, this is a permanent activity. But if we look in 2 or 3 years, we expect that the synchronization between UTM or US space and ATM will be a need, and we will be expecting which solutions are being to be developed, and we'll try to integrate them in SESAR. We will add to this center a new urban node in the city of A Coruña in cooperation with a technology center. We have here presented what we have in Galicia, what we are going to have, and we hope it's a very interesting facility for tests. And we, of course, we want to develop these projects in coordination, in particular with international and in particular European authorities, because we must develop this sector and provide the necessary places to test the technology. Thank you very much.
Thank you very much, Shema, for these very interesting presentations and for showing us the huge capabilities that we can see in Rozas Test Center for UAVs projects and the forecast for development of those capabilities. This is impressive. Rozas is part of the list of U.S.-based test centers that is also available for all participants in the network of U.S.-based demonstrators website, and it presents all the capabilities of all test centers. We can have 5 minutes for questions in this first round to Chema, if any of the participants have some burning questions for Chema before we go to Waldemar. So we could address 5 minutes questions. Let's see. Okay, so if we don't have at the moment questions for Shema, I do have some questions for Shema.
Okay.
So that we can warm up with the participants. So you have indicated that you have been in contact with the national authorities for qualification of your test centers as a SandBox. Can you elaborate a little bit more on this qualification approach? So based on which criteria the national authorities have qualified Rozas as a SandBox, and whether you will see benefits for an European endorsement or qualification of test centers in Europe as a SandBox or as a test centers for the area of UIS and UIM, including US-based. So could you give us your insights on that? Thank you.
I will put it a little bit in context. Rozas is a place where there are normal flights. So to say, there is an aero club, and in fact, the time is splitted. So August and weekends are reserved for aero club, and the other days are for THEA. Okay, so first of all, we have usually the regular flights there. So we have already a system where the THEA managers do send a NOTAM to the air traffic controllers and reserve part of the airspace around Rozas. Okay, we have an advantage is that we do not have a very high impact in the commercial air traffic. We only have a crossing point with Santiago roads. So what we have done is to approach the national authorities in order to try to streamline or to speed up the ways to provide the NOTAMs. Because the SandBox as it is not a technical concept. It's much more a political concept. It's a concept that was invented, by the way, in the financial area, and then it has been exported to other sectors, in particular sectors which are very highly regulated. Okay, so the SandBox is the place where you can test the impact of regulation in technology and vice versa. This is basically the concept, and where you don't make any problem to the people which is out of the SandBox. You are a baby playing in the SandBox, and that's it. So there is no national regulations. There are no rules for SandBox or even for test approvals. There are some rules which are there for the airspace system, for the traffic control, etc., and we all are forced to follow them, of course. But what we are doing, for instance, with our authorities, is to try to have a kind of LUC, you know, the light unmanned controller system, in order to be able to have the airspace reserved in shorter times than we have now. But there is no regulation, and it doesn't make a lot of sense, in Europe at least, to have a national regulation. Of course, the normalization or standardization of this kind of installations should probably be led by Europe. Of course, I don't want to put you much more work on the table, Maria, because we all know that you have been hard workers for a long time. But it will come a point where it will be necessary that someone makes a general umbrella for the national ways of saying, okay, in this installation, we can test things that are out of the rules, and we limit it to that, and we put these conditions already. It's not much more of what is a SORA or things like that, but it is specific for installations. I think it is necessary, but you will need to take the necessary steps, probably in cooperation with EUROCONTROL, with national authorities, etc. Of course, yes, because there is no one can put the thing, I am a SandBox, because nobody knows exactly what is a SandBox. And in fact, it could happen that there are not 20, but 2 or 3 different kinds of SandBox in this, at least in this area. Okay. I hope to have answered your question.
Absolutely. Thank you very much, Shema. Very, very clear. You are right. A SandBox, already from the definition of what we understand, and the fact that the whole purpose is to test technology for which the rules are not established, or to test new technology in order to comply with the rules. Of course, how to prove that it will be a challenge for authorities, and we need to look into it. Very quick question, while I'm still monitoring the question and answer. Very quick question. Anyone which have a UAV or which wants to test their US-based system and applications, can just they go contact you and go and use your facilities to test either their UAV's onboard system, their connection of the UAV to a UTM system, or the UTM system, or all of them? So can they just go say, okay, I have this project, I want to use your test facility, and they just can go there, plug and play the test?
Okay, yes, the facility is available for anyone. Of course, there are some tariffs. It depends on what, which is how broad is the number of facilities that you want to use. If you just need the telemetry or just the runway, or etc., there are specific tariffs. If you need the space, if you need different elements. But yes, for the systems that are already installed, there are specific services. If you need, for instance, if you are trying things that are very much dependent on wind or on lateral wind, etc., you can even have a contract as a part, optionally, the micrometeorological weather forecast, and you can use them without any problem. So the restrictions can come from your side. For instance, it depends on how advanced is your technology. If you need some kind of privacy, etc., there are hangars there that can be also rented, and there are many offices, meeting rooms, etc.
Very good. Thank you very much, Shema, for the presentation and for trying to answer to this initial set of questions. We go now to the next speaker, and there may be for sure further questions afterwards. So thank you very much, Shema.
Okay.
So good afternoon, Waldemar. So now next to the very exciting presentation on your solar power aircraft. Unmanned aircraft system. Thank you. The floor is yours.
Thank you very much. Thank you for organizing this meeting and having me here. And also thank you to José. So I found it was a really interesting presentation, and we will for sure have an offline discussion about the possibility to test your system. That's very interesting for us indeed, and I'm looking forward to that too. I try to share my screen. I hope it works. You see it?
Yes.
Fantastic. Yeah, Waldemar Krebs. I'm the Business Development Director for EASA, and I would like to present you today our basic idea, our vision, the way how we generally operate. It's really a long-range drone, and how we see this. And then I would like to show you also some BVLOS missions, some particular missions which I found hopefully is interesting for you. And then yeah, I'm also of course very happy about lively discussion and questions. So to start very simply, by the name of XSun, what it stands for, I mean, X stands for innovation. It is really a truly innovative piece of technology with seriously rocket science, and I will come to this point later. There are a lot of quite state-of-the-art ingredients inside of the drone or of this small plane. And sun is, yeah, it's a sun, the environmental sustainable energy which we use to have this enormous capacity of 12 hours flight, which is I think very particular about us, and also this payload of 5 kilograms, which helps us to really roll out professional missions as you would roll out with a helicopter or with a plane. And yeah, that is how it looks like. So it's a simple full start. Small plane. It can start also from a runway if we get a gear. You push the button, and then it goes completely autonomous, completely safe, reliable, operating. Has this particular structure you see with these two wings. This is of course for us the possibility to bring more solar panels on the wings, but it also makes the drone flying slower and stable. It's also more stable against turbulence in this way, because we have simply shorter wings. We operate. Here is a belly landing. We can also, as I mentioned, put wheels on the drone. We can land on the runway, but this way it lands quite slow, so it's quite safe for the embedded sensors on board. That's a little bit to the team. The founder of XSun, Benjamin David, coming from space, as many of us, including me. I'm also started my career in a German Aerospace Center about space, actually about the impact of air traffic on climate. So I support this project really by heart. And there's a lot of space technology embedded. Benjamin was the head of the Galileo program, and these bits and pieces what we put together and what he puts together with the team into the drone, that makes really difference. So if you cook with good ingredients, to make a little bit of analogy, then you still need a good recipe, but the likelihood that is a good result is higher, and we definitely do that. I will come to this point later. Yeah, it's a team. It's a mixture of mostly, of course, very young people, but also we have some very experienced employees as well. And I would be part of the let's say older generation in the team. And maybe our chief pilot has also 20 years of experience in operating helicopters, manned planes, of course, and a lot of different kinds of drones. But we have really young stars here, drone world champion, and with all together we build up this service and roll it out. And it's very important for us. It's truly environmental friendly. It's in the center of us, and I mentioned already, it flies very similar like a helicopter with approximately 50 kilometers per hour, and operates for aerial survey very similar. And but if you compare it with, let's say, a standard one engine helicopter, it just not blasts out 100 kilogram of kerosene per hour. And if you just make a simple math, it makes really 4 tons of CO2, which you can save with that. And so we really use the solar energy, and because of this usage, we can be more business sustainable as well, and can embed also professional payload. And we can fly 600 kilometers. I mean, it's a number. It's easy set. If you fly 12 hours, we flew 600 kilometers. We've shown this. If you fly 5 hours, 550 kilometers per hour, it's just make 600 kilometers. What does it mean? If you draw it on the map, it's kind of a stunning range what you achieve. And that's the unique part of a XSun. It's a really long range capacity. So technically, we just can do that, and we've shown this as well. Here, this is the energy on board when we did the 12-hour flight just last year. So you see it in green. It was the predicted solar irradiance. It was a more sunny day even, at least until 4 o'clock. Then we had some clouds, and the solar irradiance dropped. And in blue, it's a predicted energy on board, and in red, it's the real energy on board. So we see we start at 8 o'clock in the morning, and the energy drops until, let's say, 10:30, 11 o'clock. Then it's really stable. We not lose energy. We just get more energy even around 3 o'clock than we use for our propulsion. And then with the clouds, okay, the energy is going down again. And when we landed at 8 o'clock in the evening, we still had 30% of battery left. We could still ongoing for another 3 hours. So that's what we can achieve here with this additional solar power. That's stunning. And it's not only the way that we operate CO2 free, it's also very silent. And that's important as well. Nobody really likes the noise of a helicopter above his house. And we use here excellent rotors with a huge efficiency, and I mentioned already, it's rocket science. And it's truly the same kind of vendor which maybe you heard a couple of months ago. The Mars sonde was flying. It's the same rotors which we use, and that makes the difference. And after 100 meters, it's 42 decibel, which is really this is just a noise in the background, so you cannot recognize the drone from the noise outside. It's truly silent, and that's important also for species, for natural habitats, for natural reservoirs. We've flown a bird resort, and you can do this for 6 hours nearby in 100-meter altitude, and you can do this with a helicopter as well, of course, but you will see a lot, but for sure no birds anymore after 6 hours. And this was completely perfect, not intrusive when we did this mission. I will come to this later. Okay, this is the part where we are using this additional power on board, which is also important, of course, is the permission to fly it, and everything starts, of course, and everything is central about safety. So we have 5 kilograms of operational payload on board for sensors of different kinds, LiDARs or cameras, but we have also 3 kilograms of safety payload on board. We use a parachute, we have an IDSB transponder, RTK, IMU, all this stuff is of course also important. And in the center is also a precise autopilot, a certified autopilot, which is of course encrypted and very safe as well, and very, very accurate in its position. That's important. I would say that's the most important piece of the safety equipment on board the drone. And we have different communication systems here on board, which are all redundant. So whatever the drone takes, the system it has, and optimizes the communication to the ground station. We can use cellular 2, 3, 4, 5G if it's available for the communicating for both the data transfer, but also of course the control of the drone. If we are beyond, let's say, any reception of a radio link or cellular, we have a global connection to the drone with a, let's say, low resolution video even, which we can stream via Satcom Iridium. And we have this, let's say, radio link antenna, which is again an encrypted radio link, where we can really let the drone fly. And this, if you just an example, establish several antennas as a mesh here, you could always stream a very high resolution video of 5 per second to the ground station, and that's quite interesting as well as application. Yeah, and that's here how the drone looks like in some numbers. It flies, as I mentioned, approximately 50 kilometers per hour. It's cruise speed. It can go up to 90 kilometers per hour. It can fly also quite gusty, very windy situations because of this particular configuration of the shorter wings, and also the controllable. All wings are controllable as well, and it's very safe. So if one of the motors will fail, it will even without one motor start, only with one system. We have a lot of power on board, and we have this different sensor which are used now for operational missions like the Sony Alpha or Phase 1 or Regal, LiDAR scanner or rear gimbal, where we infrared like the long wave infrared thermal sensors, and we can put also several sensors together. It's enough payload for having several on board in the drone. And yeah, that's the summary. So it's long endurance, silent. It's very easy to deploy and pack together and go. We went to a mission in Thuringia, then we packed everything. We went to Bavarian Lake, where we did a nice video for us. It flew another hour, so it was quite easy to set up and roll out the mission. It's a low maintenance system. It's an electric propulsion. It not requires a lot of maintenance. We have this global coverage on connection. It's very safe. 5 kilometer payload. And with this, we roll out the mission. So I hope I come to the really interesting part of the talk. We operate in several verticals, of course, in infrastructure. I mentioned already, we fly similar to a helicopter, can have similar sensors, and that's needed in critical infrastructure like power line monitoring, which we rolled out in the past. Or we are always pleased to be in an environmental project with ourselves, our environmental supporting technology. Maritime, our headquarters is based at the sea, the Atlantic coast, so we can easily roll out and test maritime missions, and of course, agriculture. And we have plenty of clients who work with us already and would like to work with us in future. We have two business models. One is to sell the drone, of course. We are a manufacturer of the drone. We sell it, but we also roll out services. And this is what I would like to show you, what kind of services we did in the last, let's say, couple of months, which I think are interesting for this talk. And yeah, and for rolling out the missions, of course, the most important part, we have the capacity, is do we have the permission for the mission? And at the moment, we operate in specific category at Sail 2, which limits, of course, our capacity. So it limits us to rural area, and that's a challenge, because the most interesting part is, of course, in the urban areas where the assets are standing like buildings and things where people live, and there we want to look, but yeah, to get there, it's we need really Sail 6. So if you want to fly in the center of Munich, for instance, you need Sail 6, and or even certified level. And we work on that. We want to achieve that, and all this use-based discussion, all the digital infrastructure Europe builds up. This is really important for us, and to come to this point as soon as possible, because this would improve also I think, the whole drone industry capacity for being also sustainable in terms of business. So we have, of course, the permission. We fly BVLOS in France. We have also some projects ongoing in Germany, where we work also on this and appreciate very much the EU regulations and the homogenized EU regulations, where we can use our approved SORAs and transfer them to other countries. That's actually makes our life much easier. Of course, it's for everybody, including the authorities, also a learning process here. But in general, we completely appreciate this idea, and yeah, that is a very helpful part of the regulation. Oh, this is I just skipped this slide. It's where I'm based. Actually, I'm based at the Edinburgh Airport of the German Aerospace, and test this particular possibilities for testing as well, where you can fly until 3,000 feet, which is, of course, much higher than normally operational area for BVLOS flights. So now I come to the missions. So this is what our clients ask us. So this is a desired mission for a client. Let's say, want to disclose the name, but it's a pipeline company having this pipeline here in France. And to roll out this, we really need more than the possibility we have with sail 2. We really need minimum sail 4, maybe 5, to go really beyond visual line of sight for the entire track. We did for part of the track for 8 kilometers. We rolled it out, and these are other missions we did in the past. So here, this is the missions which we fully rolled out. It's a 1 hour and 10 minutes flight. It was photogrammetry flights. We took pictures and then created an autophoto out of that. This is what the client requests us to do for checking the area for potential problems here. And we flew 8 kilometers. It's for sure a BVLOS mission, of course. But we would like, of course, to go for really the full area of 100 kilometers and fly completely. And we will get there. I'm sure about that. And the development on regulations are really going into this direction. Another flight, this was our first mission, like smaller, shorter flight, but also already BVLOS for inspection of power lines. Or also an inspection mission, again, quite a short mission, but still already 4 kilometers. You see, we have several roads which we flew, and this was about road maintenance, 1 centimeter resolution data. And yeah, this is what we can do at the moment. You see, we use just 9% of the battery, or we cannot really completely use the capacity. Sometimes, though, we can. And okay, here this is again a rail mission. So you see, it's very similar. We just fly, take pictures, and create autophotos out of that. And this is an agriculture mission. 50 minutes flies, approximately 12% battery used for binary fields. Nice project. And we could go really from one field to another to really cover quite big area here. That was for sure also a nice BVLOS mission. And here, this is already something, I would say, it's very interesting mission. 1.5 hours for the aerial survey of an airport in Germany. We really operated here within the CTR, so we've been all the time in contact with the tower, and there was also air traffic ongoing, so we had to go into a holding. So all these rules, this is really important to us. If we can improve this, if we can fly safe and operate especially here in this control space. In principle, we are liking this because we are then really have more awareness about potential air traffic ongoing. We not only operate in the sun. This is something I would like also to show. We are truly solar sunny boys, or sunny girls as well. But we can also fly in the rain. This, you see, we can also operate on the sea in January in Brittany, and under really heavy rainy and also gusty conditions, and we liked it because we have, of course, much lower ground risk here, or zero ground risk in principle. So these are the missions we really appreciate. But to really appreciate, it's part of just a thermal, the multi-sensor capacity. To really appreciate missions like this, here we flew 6 hours, so on 5 hours 35 minutes. We used 62% of the battery. It was in March this year in France, and flew really and covered 1,200 hectares. So this is where really the strength of XSun is, to fly these long endurance missions and to cover huge areas, which is what was possible only with helicopters or planes so far, and which we can do. So I hope I could give you some overview. It was quite quick. I hope it was also lively enough and interesting. And that's basically it about XSun and what we do at the moment. And we are happy to hear what we can do else. Thank you very much. That's just a funny slogan, but we use what we do, saving the world. Thank you.
Thank you very much, Waldemar, for this very interesting presentation to guide us on the interesting projects you are doing. As you said, it seems to be rocket science, what you have developed, and very interesting applications. And so we have 2 questions. so which I prefer we answer first and then we see. So the first question is, do you use GNSS in your missions, so GPS, Galileo, augmented by EGNOS? I guess for navigation purpose, you use that, your experience with that?
Yeah, okay, we use that, what we use for standard aerial survey. So we use, of course, GNSS available. So all the GLONASS, Galileo, and Baidu, whatever is available. So everything can be received, and we use it, of course, for the production. It's important. It's not, let's say, if you have ground control points, it's you can also go without, but without ground control points, it gives you simply a good position of your result. And of course, for the position of the drone itself, it's also quite useful.
Indeed. So for missions at the airport, do you use temporary restricted areas, segregated space?
Yeah, we sometimes we ask for that. Yeah, it depends simply on the mission. Yeah, so we ask sometimes for segregated airspace. It wasn't mostly necessary, so we simply follow the instruction and operate based on the advice of the tower or the command of the tower. So, for instance, when we flew in the this pipeline monitoring was also within the CTR of Saint-Nazaire in France, and at least some part of it. And the Altenburg mission, where we flew in Germany, we had a direct contact always with the tower. So as any other pilot who would be in the air and fly in the CTR, we just listen to the radio commands of the tower. And then there was also some traffic ongoing, so they told us, okay, now there's a helicopter coming for landing, so we had to go into a holding, very standard like a plane, very similar, or just the same.
Very good. Thank you very much for the answer. So we have Kairos Bitmantas, who would like to know if you could indicate if it would be possible to have the cost per hour. And there is, of course, another question related to your business case. So it's, are you at the full potential? So how would you see the business being developed in your area?
Yeah. So okay, the price it depends. It really depends if you want to use a Regal VUX 120 lidar. Yeah, that's of course also some amortization to this device. We can have an offline discussion of that for sure. I bet we are very, very, very attractive by the price. That I can promise. But we will take it on the specific needs, and then we can find a good price for you. That's for sure. We operate 12 hours. Sometimes it doesn't make sense to operate 12 hours. Sometimes it does. In LiDAR, you can principally fly the whole day, and even in the night. We can also operate in the night, by the way, for 5 hours. It's quite a long time. And it depends simply what kind of equipment, what are the requirements of the sensors. But it is very efficient compared to standard drones. It's very efficient. It also compared to helicopters, because we have no fuel costs at all, and they are significant for helicopters, for instance, and also for planes, of course. It depends also on the resolution, what you need. Yeah, if it's about 1 centimeter resolution, I think then it's hard to beat this drone, also commercially.
Indeed. So we have few questions related to the SORA. So there is one specific question which relate to your particular aircraft design, which are with a wingspan of 4.6 meter, but the indication is that you consider the drone in your SORA application under 3 meters. Maybe this is the question is, how is that possible? I guess it's you have different prototypes of aircraft, but if you want just to elaborate on.
No, the 4.6 meter is all right. I mean, this is an old rule where we had, and in some countries it's also different from country to country. These 3 meters they appear, but by the European regulation it doesn't matter. So the 4.6 meter are completely the same. So we operate in specific category under CL2. This is what I can say, and pretty much always under SORA. It doesn't matter in principle that is bigger than 3 meters. Nevertheless, we are discussing with some authorities who have this particular restriction just from the previous regulations, but the EU regulations, for us at least, as we see it, are clear. But as I mentioned, this is a learning process for everybody, also for the authorities and for us. And we are in very constructive discussions with several aviation authorities on that, and everybody's kind of trying to help and then get here things good designed. Important is that it's safe, and we placed a lot of safety equipment on board on that, and then
yeah, the 3 meters is a parameter also in the European regulation, but it depends on where you fly, in which areas. But there is another question, I think, generic on the SOAR application. So you have now got an approval by the French Civil Aviation Authority for conducting SAN operations, and you are undergoing also an approvals in Germany for your operations. Are you considering to have a certification as a light UAS operator certificate?
yes.
Are you considering this?
Yes, it's an interesting part. It can, of course, increase a little bit the predictability of some projects. This is important from business point of view. If there's a lot of similarities, so definitely we look into that. And more important, I would say, is really that we increase the sale level, and we are in the process of that. It's of course quite challenging as well for, let's say, quite enormous amount of documentation you have to go through. We have it, and we are in talk with the EASA on that. We will get it. Both ways are important. We just go in parallel on both.
Indeed, that is very important. In relation to the certification of the aircraft, you are saying you are in contact with us. I know you are in contact with us. The question then Rudy Muller has is with regard to the certification of the flight controls. You are applying actually software standards which are applicable for traditional aircraft as well. And so the question is, what is the benefit of a certified flight control while the GNSS is not TSO certified, said EGNOS and Galileo? It's a very specific question. I don't know if you want to address that right now, but quite specific.
That's really a little bit specific. I mean, in general, I can answer that the certified level is that is the goal, yeah. Because from a business point of view, we need something which is of course capable of operating in the city center of Paris. That's what we want. Then really we can be that's not excluding, but then we can fly over the most valuable assets, and from a business point of view, that will create simply a bigger business, and of course the society will benefit and fully from this potential of not only us. I mean, this is probably true also for other drones and the drone companies, unmanned plane companies. So that's a general question. The particularity of, let's say, several certification bits and pieces. Yes, every part needs to be certified. The vendors need to be certified. The data, the software process, the plane from scratch needs to be built certified in a quality process. It's quite a complicated process, starting with ISO 9001, and then goes beyond that. So that's I think there was a very interesting presentation by the UAV DACH, I think 1 month ago, about all the different particular levels of the certified process. We started it, so we will go there. So it will be tough, but we will get there.
Sure, you will get there. We have seen that in many missions, actually, you are not using the full capacity of the batteries. That is amazing. Basically, the capacity of the batteries. The questions are about the lifetime of the batteries, and what will be battery endurance be on the overcast twilight and night conditions?
Yeah, it depends, of course, also on the environmental conditions, what kind of wind you have, and so on, and also how much clouds. But if it's really night, and that can be 5 to 6 hours, so something in this range. Maybe it's windy, that's only 4, but if you have a go against, so it depends really on the environment, like for every other plane as well. So if you take fuel and you have a windy condition, then you use more. And but it is also, let's say, if I make an average of 5 hours, so it's also in the night a long range plane, that's for sure. So it has quite a capacity on board, and there's also a lot of battery for sensors available. We have a lot of power for sensors, for LiDAR, for whatever you want to sensor, in addition to the flying capacity.
Very interesting. Thank you, Waldemar. Additional question is, how do you see the use of U.S.-based and U.S.-based services to support actually the full potential of the operations that your aircraft will be able to achieve? You have said that today the full potential is not achieved in the majority of the missions. So how do you see the US-based supporting this?
That supports definitely. We appreciate this very much. I mean, therefore, as I mentioned, the most important is the safety of operation. U-Space gives additional safety and additional information which can be used for safe flight, and it's highly appreciated by us. That's we see this development. We see, of course, that there's a digital infrastructure for airspace ongoing in development in Europe. It's a European, let's say, strategy, and that's for sure, for not only us, I mean, for the entire industry, very, very helpful.
So what else do you think you will need to support you in terms of regulation, in terms of technology, in order to get to the full potential of your ideas?
Yeah, I mentioned already a digital infrastructure, this additional information, updated maps, things like that, availability of this data. Also the let's say the up-to-date state of the data is also important for that. So it's because there's a lot of change, especially in areas with population. There's a lot of changes, and an ICAO map is simply not enough. We fly close to the objects. Trees grows. I mean, they can grow in a year by 10 meters. So we really need more up-to-date maps for better planning. And in addition, of course, I mean, this was interesting, what José also mentioned, all this avoid and detect systems, and they work in combination with all this digital infrastructure and can be improved by that. So that's
indeed
in a nutshell.
So a lot of the really potential in this aircraft, and I guess this will not be the end of your developments there. There is another question by Raymond Martin, who questioned, when operating near an airport, an airfield, do you use the same procedures that ATC provide for manned aircraft, or are they determined specifically by ATC provider for your particular flight?
So I mean, there's always a
communicate to ATC. Do you have, for instance, an ADSB out in your aircraft?
Yes, we have. And there's I can just only tell about the EDMO, the Oberpfaffenhofen airport. There's simply specific rules how which are applied to us. So it is similar, I would say, to manned aircraft, but not the same. Yeah, so we have a specific agreement with the airport to operate there, and we had also a specific agreement with the airport of Altenburg, how we communicate there, and how we can arrange a safe flight. And we discussed this with the airport previously, and then we roll out the mission. And that's again, we create a SORA, we create or extend our existing SORA to the specific conditions of this particular geographical region within the CTR. We have to analyze all risks. So it's a quite a sophisticated process. It goes beyond that. You just go into an airspace, say 5 minutes before you enter the CTR, contact the tower and say, I'm here. It's different.
I can imagine. Thank you very much. May I ask now to Shema to join the discussion as well. And this is perhaps a question for the two of you. How would you see the demand of the Shema in your test center? So what is the demand at the moment on UAS projects to be tested in the test center? And what is the demand for you, Waldemar? Perhaps first, Shema?
Okay. We basically, up to now, we have had 90% of the demand comes from the Galician UAVs program, up to now. In fact, the test center was initially oriented towards covering the local demand, because you cannot launch such a program in which you invest tens of millions of euros to develop the industry without a place where to make minimal tests of technologies and solutions, etc. So up to now, it has been like that. The design of the infrastructures, the technological assets, and the coming infrastructures is done to broaden the number of the potential use of it. Okay. We know that there are not many places really in Europe with such a potential as we have there. We haven't done a very broad commercial activity up to now, because you first need to put things running and to have them tested, etc. And we expect a high increase in demand very soon, because we have already approached by a couple or 3 companies. Some of them are basically confidential, because people is developing a lot of projects around the world, and we have approaches from not only from Europe but from other continents. And we know that with 1 or 2 big programs, we are probably crowded of work in a few months. So we know that it will explode at a point in time. We don't know when it will happen, but we are sure. And of course, we want to maintain part of the capabilities of the facilities for the local industry. But we also look for cooperation of the local industry with everyone in Europe and around the world. So we expect that we will have probably a lot of people going there. In fact, this is just a point. Just beside the aerodrome, we have developed an industrial park in which we already have 2 companies installed. And we will develop this industrial area in the coming years. So we hope that the offer of the test center, the industrial area, etc., will help, will create synergies, and will help to develop the activity of the test center.
Yeah. So I can only confirm this. I mean, I'm very careful to listen to José and appreciate his presentation. So it's definitely very interesting and important. Of course, I mentioned already, we have a lot of safety systems integrated. We integrate even more. We continuously work on that. And yeah, you need to test this. And that's absolute fantastic that we have a place. So I mentioned already, hopefully we can have a offline discussion on that. And we'll see.
Yes, yes,
So,
of
but
course.
for sure, interesting for us. Yeah, and,
It's done for it.
That is the network, the purpose for, to connect people. Waldemar, in terms of your business, so that's it. So are you having demands sufficient to your investments? So it's a business case for your operations. Are you having many applications of your drone for many demands of your drone?
You see, it's growing. We have already missions ongoing. We have commercial operations with our service model. We have also serious requests just for buying the drone. We are happy also to sell it, of course, from different verticals. And it's never enough. So it can be more for sure. I appreciate this. So if there's if here in this audience is somebody who is interested in our services, we are simple to work with. We take care about the regulation. I think we understand this very well, how to go through this challenging process. Come to you, we make the mission, deliver you the data. It's very simple. We charge per day. So yeah, I mean, can be more, but it's growing. We appreciate the interest coming, and it's getting more and more. That's for sure. Very interesting clients, I have to say.
So very promising, the two business models and how they are growing. So thank you very much, Waldemar, and thank you very much, Shema, for the very interesting presentations and very interesting insights on the forecast of test centers and the forecast of very long range BVLOS operations in Europe. So I would like to remind the participants to please don't forget to fill out the feedback form before you leave the Zoom. I would like also to thank you very much the participants for the active contribution and the questions, and to have also joined this webinar on a Friday afternoon. I insist that shows really the interest that there is in the industry. And with all this, I would like to close the webinar. Thank you to EUROCONTROL for hosting this, to Munish and David and Simon for all the arrangements that made this happen. And I would like to wish you all a very nice weekend. Thank you very much.
Thank you very much.
Thank you a lot.
Maria. Thank you, Munish, David, etc. Thank you.
Thank you. Thank you for organizing this and making it possible.
Exactly. Don't forget, we have another webinar which will be on the 28th of June. Yes. So we're looking forward to see you all there again. Thank you very much.